Now that we've talked about gases, let's use the same kinetic molecular theory that we use to describe the behavior of gases to compare some of the different phases of matter. Besides gases, we also have liquids and solids to think about. There are some other crazy phases like plasma, but we're going to not really dwell on that and just focus on the big three: solids, liquids, and gases. And let's compare some of the different properties of these different phases with respect to each other. Okay? So the big difference between gases, liquids, and solids has to do with the relative magnitudes of two things: either intermolecular forces or intramolecular forces. Inter is between one particle or molecule and another. Intra is within the same particle or molecule. Okay, and so let's look at gases. These are the ones that we studied already. Okay, gases have an indefinite volume, which basically means they take the volume of their container. Right, if the container is a certain size, then the gas is going to occupy that same size of the container. They also have an indefinite shape. Right, whatever shape the container has, that's the container's. That's the same shape that the gas is going to occupy. Okay. They also have a very high compressibility. You can think of compressibility as how squishy something is. Right? If I apply pressure and push down on something, how much does the volume change? Something that's highly compressible, I can apply a little bit of pressure and change the volume very dramatically. Okay, so we say that gases, for the most part, are highly compressible. That's what we saw from Boyle's law. Another property is fluidity. Fluidity basically means how well does something flow or move. Okay, and so here's where English and science don't always agree with each other. When you use the word fluid in typical conversation, you usually think of a liquid. But as far as scientists and engineers go, gases are also fluid. Okay? Anything that can kind of move around pretty easily and do this is considered a fluid. Okay, and so under those definitions, both gases and liquids are considered fluids. So speaking of liquids, liquids have a definite volume, and I kind of wish they didn't, because then if I had coffee in my coffee cup and I just kept having an indefinite volume, I could just get more and more and more and more coffee inside my cup, but eventually it runs out. Okay, and so unlike gases that have an indefinite volume and just kind of occupy the entire container, liquids and solids don't do that, right? They have a definite size to them. Liquids have an indefinite shape, right? They'll occupy whatever shape the container has. They also have a fairly low compressibility, right? They're not so squishy, but they do move around, so they have a high fluidity. And then finally, to compare that to solids, solids have a definite size and a definite shape, right? These are the most rigid of all. A very low compressibility, right? Pretty hard to change their volumes when you apply pressure. And because they don't typically move around too much, they have a very low fluidity.